आज के इस वीडियो लेक्चर में हम लोग स्टॉपिंग साइड डिस्टेंस के बारे में स्टडी करेंगे। जैसा कि IRC 73 2023 में दिया गया है कि वह लेंथ रोडवे के लॉन्ग कौन सी होनी चाहिए जिसपे वह जब कोई स्टेशनरी ऑब्जेक्ट देखे तो अपनी गाड़ी को सेफली स्टॉप कर सके। सो लेट अस स्टार्ट द स्टॉपिंग साइड डिस्टेंस। सो स्टॉपिंग साइड डिस्टेंस it is a minimum side distance available at any spot of the roadway. Of sufficient length so that vehicle traveling at design speed can stop upon seeing the obstruction ahead of him. So of sufficient length to a vehicle traveling at design speed enable to stop the vehicle collision without collision with stationary object. In spot जब कोई व्हीकल ट्रेवल कर रही हो डिजाइन स्पीड से, तो जब कोई स्टेशनरी ऑब्जेक्ट देखे अपने रोडवे पे, तो उसके पास इतना सफिशिएंट लेंथ होना चाहिए कि वो अपनी गाड़ी को रोक सके। अब उसको दो पार्ट में उस लेंथ की रिक्वायरमेंट होती है। द मोमेंट वो व्हीकल जब वो किसी ऑब्जेक्ट को देखता है तो उसके मन में एक भावना आती है कि अब करना क्या है, गाड़ी को रोकना है, पास करना है, उसका एक टाइम उसमें चला जाता है। जबकि जो व्हीकल होती है वो अपनी स्पीड से चल रही होती है, तो इन लैप्स टाइम, जिसे लैग डिस्टेंस भी कहा जाता है, कितना व्हीकल ट्रेवल कर लेगी उस लैग डिस्टेंस में, दैट इज बिफोर एप्लीकेशन ऑफ द ब्रेक। तो जो एक लेंथ जो ट्रेवल करती है वो, और फिर ब्रेक के बाद में जो काइनेटिक एनर्जी ऑफ द व्हीकल होती है उसके द्वारा अगेंस्ट द फ्रिक्शनल फोर्स जब तक रेस्ट में नहीं आती है, डिस्टेंस ट्रेवल करती है, तो दोनों को मिलाकर स्टॉपिंग साइड डिस्टेंस होता है। तो स्टॉपिंग साइड डिस्टेंस दो कंपोनेंट में होगा। एक तो व्हीकल ट्रेवल ड्राइवर परसेप्शन एंड रिएक्शन टाइम, दूसरा अपॉन एप्लीकेशन ऑफ द ब्रेक, इंस्टेंट ब्रेक एप्लीकेशन करेगा तो व्हीकल कितनी डिस्टेंस पे जाकर के रुकेगी। तो दोनों डिस्टेंस के कॉम्बिनेशन को स्टॉपिंग साइड डिस्टेंस कहते हैं। तो स्टॉपिंग साइड डिस्टेंस ये जो स्टॉपिंग साइड डिस्टेंस होगा, ये डिपेंड करेगा रोड के फीचर्स पे। वर्टिकल अलाइनमेंट है, हॉरिजॉन्टल अलाइनमेंट है या स्ट्रेट रोड है, तो इसका जो लेंथ होगा इट विल डिपेंड ऑन द रोड फीचर। और ड्राइवर की आई हाइट फ्रॉम द रोड सरफेस। ड्राइवर वो कितना ऊंचाई पे बैठा है, जिससे वो कितना लेंथ को देख सकता है। जितना ऊंचाई पे बैठेगा उतना ही इसको रोड आगे क्या कहते हैं ज्यादा विजिबल होगी। इट विल डिपेंड अपॉन द ड्राइवर आई फ्रॉम द रोड सरफेस। फिर हाइट ऑफ द ऑब्जेक्ट कितना है, जो ऑब्जेक्ट को विजुलाइज हो रहा है कितना, तो उसके ऊपर में भी डिपेंड करेगा। हाइट ऑफ द ऑब्जेक्ट इन IRC, जो फॉर कैलकुलेशन ऑल कैलकुलेशन पर्पज एक पैसेंजर कार को लिया गया है, जिसमें ड्राइवर की हाइट फ्रॉम रोड सरफेस 1.2 मीटर 1.2 मीटर 1.2 मीटर लिया गया है। और स्टेशनरी ऑब्जेक्ट ऑन द रोड सरफेस उसकी जो ऊंचाई ली गई है दैट इज 15 सेंटीमीटर, वो 0.15 मीटर ली गई है। तो जैसा कि हमने पीछे बताया कि जब कोई गाड़ी रोड पे ट्रेवल कर रही हो, अपॉन सीइंग एनी ऑब्जेक्ट, उसके पास एक टाइम जाएगा उसको परसीव करने पे, उसके रिएक्शन में, उसके एप्लीकेशन में, ब्रेक रिएक्शन टाइम, फिर वो ब्रेक लगाने में। तो दैट टाइम लैप्स इज नोन एज लाइट डिस्टेंस। और इसको जो व्हीकल की वेलोसिटी होगी और टाइम लैप्स उसके मल्टीप्लिकेशन से पाया जाता है। तो वेलोसिटी ऑफ व्हीकल जो भी डिजाइन स्पीड होगी या जिस भी स्पीड से चल रही होगी, और उसका परसेप्शन टाइम जो कि 1.8 सेकेंड तक से 2 सेकेंड तक के बीच में होता है, पर फिर भी IRC में 2.5 सेकेंड दिया गया है। तो टाइम लैप्स विल बी 2.5 सेकेंड फॉर ऑल कैलकुलेशन पर्पस। सो लैग डिस्टेंस डिस्टेंस कवर्ड ड्यूरिंग द ड्राइवर्स PR टाइम, इसका वैल्यू होगा डिस्टेंस कवर्ड बाय द व्हीकल इन PR टाइम, that is given by dr, and it will be velocity multiplied by time. So dr will be equal to v into t, and the braking distance will depend upon the kinetic energy of the vehicle। और जब काइनेटिक एनर्जी को हम जब स्टॉप करते हैं ड्यू टू ब्रेकिंग फोर्स, तो ये गाड़ी रेस्ट में आएगी ड्यू टू frictional force applied between the tire and the road surface. So how to find out braking distance? Let us see the calculation of braking distance. So we know that acceleration होता है उसे rate of change of velocity। तो ये कोई व्हीकल की इनिशियल वेलोसिटी u रही हो, फाइनल वेलोसिटी v रही हो, तो v माइनस u, फाइनल वेलोसिटी माइनस initial velocity divided by time will be known as a acceleration. So v is equal to u plus at, v is equal to u plus at, that is kinetic energy का फर्स्ट लॉ भी है, kinetic motion का फर्स्ट लॉ भी है, v is equal to u plus at। How we derive it? If initial velocity is u, final velocity is v, so v minus u by t will be the acceleration, and then v is equal to u plus at, and we find out time v minus u bar a. Now second, we know that distance is velocity into time or speed into time. So there will be average speed, uh, initial speed upon when the vehicle has started, and the final speed where we are making the measurement. So average speed will be, if initial is u, final is v plus u by 2, and time taken by that vehicle is t. So v plus u divided by 2 into t is a s, means distance will be average speed v plus u divided by 2 into time. So we can find out v plus u upon 2 into s will be the time. Now we equate both the time when the vehicle taken in accelerating from u to b and distance covered during that period. So v plus u upon 2s, distance covered during that period, equal to distance when the vehicle has accelerated from u to v minus u upon a. So v square minus u square is equal to as. It is also kinetic energy का third law है, v square minus u square equal to 2as. And then since initial velocity of any vehicle would have been zero only, it has started from zero, it started accelerating in time t v. So u will be 0, v square equal to 2as, or we can say as is equal to v square by 2. Now work done by, we know the kinetic energy is work done in motion. कोई भी moving body जितना distance cover करती है, so that is work done by that vehicle in motion. So kinetic energy is work done in motion, that is force due to acceleration into distance. So force due to acceleration is Fa into s, and we know the Fa is nothing but m into a into s, and we found out the as is v square by 2. After putting the value of v square by 2, we found kinetic energy Ae is equal to mv square by 2. Now this mv square by 2 will be, when the brake has been applied, it will be resisted by the frictional force. Vehicle will come to stop after the kinetic energy is exhaust due to frictional force. So kinetic energy will be equal to frictional force due to road surface and the tire into distance covered. So the braking distance will be L, or we can say distance due to braking dV. So Ke is we found mv square by 2. F is we already know the relation between F and the gravitational force, means weight of the vehicle. So mu is equal to F upon gravitational force due to the vehicle its own weight. So mu into Fw is equal to F, and Fw is nothing but gravitational mass into g, m into g is equal to F. So let us input that mu into m into g into L. M get cancelled. Now v square upon 2 mu into g is equal to L or dv, distance covered by vehicle after application of brake. So in this case, side distance will be the lag distance, that is v into t. So stopping side distance will be equal to lag distance v into t plus braking distance v square upon 2 mu into g. Mu is also coefficient of friction, is also represented by F. Friction coefficient F is taken in the highway engineering, so we can replace this mu by F. So Vt plus v square upon 2 F into g. Now the v, the velocity is in meter per second, t is in second, and g is in meter per second square, and v is again in meter per second. But generally the velocity in speed of the vehicle is given in kilometer per hour. So it can be converted into the kilometer per hour by converting this will be 1000 upon 3600, 1000 meter per 3600. So it can be directly input kilometer per hour. 1 kilometer is 1000 meter, and the time taken is 3600 in traveling that 1 kilometer. So it will be directly, we can put the value of v. In the place of v, we can put this value. If vehicle is traveling with 100 kilometer per per kilometer per hour into 1000 divided by 3600, we get the value of 0.278 B. Means if here we put the km ph, so we get the 0.278 into 100 into t in second, we get the leg distance directly. And similarly, v square, if we put value of v in kilometer per hour, so v square upon 254. If we solve it, we find out 0.278 whole square into v square upon 2 mu g upon 2 f into g. So it will be v square in kilometer per hour upon 254 f. So we can solve, and the equation is for side stopping distance when the speed of vehicle is given in kilometer per hour 0.278 into speed in kilometer per hour into t in second plus v square, v will be in kilometer per hour, square it, divide by 254 into coefficient of friction. Coefficient of friction f is for 100 kilometer is 0.35, for 40 kilometer per hour it is 0.4. So the distance keep the frictional coefficient of friction value keep increasing as the distance decreases. So now if any vehicle is going on the gradient, if it is in the ascending gradient, means ऊंचाई की तरफ चल रही है, तो उसका जो gradient होगा उससे stopping side distance will be reduced. So we can take g plus that will be added. So stopping side distance plus b square upon 254 f plus minus 0.1 g. We can directly put the value of gradient multiplied by 0.01. When it is ascending, it will be plus. When it is descending, it will be the negative. Means it will require more length for getting stopped when the vehicle is descending. So this correction is done while doing the calculation when for the vertical curve. When we are taking the vertical curve, where there will be ascending and descending gradient. So accordingly, a correction is done depending upon the grade of the ascending or descending. So let us in table 5.2 of the IRC 73 for different speed, how much the side distance will be required to take into consideration while designing the highway is given. So let us solve one of them. 100 km per hour. When a vehicle is traveling with 100 km per hour, so how much the lag distance will be required, how much the braking distance will be required, and what is the provision given in the IRC. So distance distance in meter traveled by due to perception and brake reaction time. Distance traveled by the vehicle during perception and reaction time. So this will be 0.278 into 100 km per hour into 2.5, that is perception perception and reaction time of the driver. So this will be equal to 0.278 into 100 into 2.5 equal to 69.5 meter. Leg distance will be 69.5 meter, and coefficient of longitudinal friction is given mu. So how much distance it will travel during the upon the application of brake. So this is given by b square upon 254 in divided by f, and the value of coefficient of friction is given as 0.35 for the 100 km per hour. So v square 100 into 100 upon 254 into 0.35. This will be the braking distance. So 100 into 100 upon 254 equal to upon 0.35. So braking distance will be 112.48. 112.48 meter. So SSD, stopping side distance, will be the lag distance plus braking distance. So SSD will be equal to 69.5 plus 112.48, which will be equal to 69.5 plus 112.48 equal to 181.98. So design value can be taken as 180 meter. Whereas in IRC it is desirable to have 360 meter of the stopping side distance while designing the while designing any curve or any vertical curve or straight length of the road. So 360 meter should be considered for stopping side distance of a vehicle. It is provisioned in the IRC 73. So with this video I understand the stopping side distance concept will be clear, and this will be the important slide. This will be the important slide where uh, how a traveling vehicle will cover the distance during the PR time of driver. So that is B into T. Once the brake has been applied to the vehicle, it will skid and it will come to the rest due to frictional force. So kinetic energy and work done by the frictional force. That frictional force will do the work till the rest. So during that period, a distance will be covered by the vehicle, that is braking distance. So lag distance plus braking distance will be the stopping side distance. So we calculated how to find out lag distance and how to find out braking distance from the first principle of kinetic energy. Kinetic energy is equal to the work done during the vehicle upon application of brake due to skidding and frictional force developed between the tire of the vehicle and the road surface. So that is frictional force into the distance covered by the vehicle during the braking duration. It will depend on the condition of the road, frictional quotient of friction of the road surface, velocity, etc. It will depend on all these factors. So we find out how much the distance. This will be b square upon 2 mu into g, and since v is in kilometer per second square, it can be converted in kilometer per hour. So directly value can be input. So if we input the value, it will come to 0.278 in v in kilometer per hour into time or system time. It is 2.5 second plus v square upon 254 into f. So f is coefficient of friction. Generally for 100 km per hour it is 0.35, and if this speed decreases, the value of coefficient of friction will increase. So by giving input of this value, we find out the stopping side distance. When the vehicle is ascending gradient, f plus the n% whatever gradient is given, and if it is descending, it will be in the minus. Means if vehicle is ascending, there will be less stopping side distance will be required. Once vehicle is coming down, more side stopping distance will be required to stop the vehicle. So with this, I understand the concept of this stopping side distance will be clear to you all. Thank you.